Okay, so now we should gmail.com, and I just have to put in your password again. And I have to do the two-step verification, 'cause everything is awful. Everything is. Yes, it is me. Hmm. Okay, well, I see a control panel. How do I get up chat? Must be in docs. What are we doing? Stats? Oh, whoops. I just reset everything. Oh my god. Okay. YouTube Live control panel. Select stream. Refresh. Chat live stream. How do I view chat? Is it even possible for me to view chat? I don't know. Whatever, bro. I don't think it's possible for me to actually view chat on here. Okay, well. Okay, that might be a little bit too loud. Okay. We are live. We are live. Now I just need to edit the hello. Hello. Now I just need to edit the hello? 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 Okay. Live? What? Okay. Cool. Um, maybe? Live? What? Oh, it's just very delayed. Okay. Well, I'm gonna try to connect to my earbuds over here. Okay. I'm actually gonna avoid that. I just realized how bad of an idea that is. I'm probably gonna cut the beginning out of this, but I'm gonna. Oh my gosh, I don't know how to do this. How do I? Oh, there we go. Pop out check. I'm gonna avoid that. I just realized how bad of an idea that is. So I just need to pop out chat and then chat over here. I'm probably gonna cut the beginning out of this, but I'm not. Oh gosh, I don't know how to do this. How do I? Oh, there we go. Pop out. Okay, so pop out chat. Edit. Dang it. Edit, 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 and make this public. So, okay, so now the stream should be public, right? Edit, and make this public. Okay, stream is streaming. I think to the best of my ability, I think it sounds okay. Um, I'm streaming over Wi-Fi, so this may not be the best thing ever, but that's okay. I need to go prepare for this, so I'm gonna put on some music and then also fix this um, music. Okay, hopefully that's not too loud. I have no idea. Turn it down a little bit more. Actually just like straight up need to prepare for this stream. Okay, yes. So I need this here, and then I need to grab this. Okay, so that should basically be everything I need for this. Grab my coffee while I'm at it, I suppose. And oh yeah, I forgot. I need that other circuit board. That's that. I did how much to put that. Okay, so that's here. I just finished. I also have to pull up data sheets, so I don't know what computer I'm going to do that. Let's see. I'm going to turn this down a little bit more. I'll try and take this out here. Okay. So there's that. Okay, and then okay, we have our thing here. I'm also going to minimize my down here. So wait, I also want chat up. I want chat. Okay. All right. So I really don't need all of this, but I'll need that. I'll need solder. I'll need some extra wire, which is probably enough. Wait, where did I put that? Yeah, that should probably be fine. And then, if I'm going to use the 741, I need 2 voltage supplies for that. I don't even know if I'm using a 741 yet. What is what I use realistically? I guess I could use a double channel. I'll worry about that later. Okay, well, I think I should be ready now. Okay, cool. All right. Music down. I'm gonna try to like get the camera position well enough that it's not dying. Okay, here we go. Okay. Cool. So we're going to be building an amplifier, because I need to build an AM transmitter if I'm ever going to test out the radio fully. I just realize how bad it is to have a camera like in the way. I'm gonna try something else actually. I'm gonna try to like do a zoom. That way I can actually walk in front of this and not have it be so bad. That might be better, actually. Cool. So I need to build this very simple amplifier, and this is the wrong chip. So let me put this back and grab what I think is an op amp, OP27. I've used these before. This should fit pretty nicely in here. OP27, yeah, okay. So that's an op amp. Um, and let me also prepare to get a screen share open here. I wonder if I can put the screen share in the same window. That would be very professional of me. I'm gonna try that. Hang on, I have it as a different window right now. I'm gonna try adding it as another source. Display capture. Uh, yes. We're not capturing my cursor. Oh God. And then we just minimize this, put it down here. And then I can pull up the PDF and have this look very nice and professional. Uh, hang on 1 second. I need not that. I need a window capture. Firefox. Where is Firefox? OP27 PDF. Is it here? No. Why don't I see it? This is drunk. Hang on. Come on. I should have figured all this out beforehand. I know I'm really bad at this. It is only like my second time streaming ever, though. I don't even know if you all can read. Just gonna move that here. I'm so bad at this. I'll put this up here. Okay, so now I need to actually look at this, and it's really hard using one computer for everything. I'm gonna pull up the pinout. There we go. Um, yeah, okay, cool. There we go. I'm gonna leave that up there. Beautiful. All right. So I need to um, figure out what pin. I'm gonna just call the mono signal. So we have the ground, I believe, is the outer sleeve here, and then this tip should be like the signal, I think. Let me grab an audio jack just to make sure. I think I have one here somewhere. Yes, I do. So something like this. Something like this mono jack, right? So it has ground on the outer two. Oh my gosh. And then the topmost one is the signal. So in this case, if I were to do this and make this a non-inverting amplifier, so it's got a gain of at least 1, then we just need to attach the signal. Remember my op amp theory here. With a non-inverting amplifier, you attach it. So yeah, so the tip is going into the non-inverting input. And then the inverting input's in the feedback, and there's a voltage divider. Yes. Okay. So I just need to do that. I wonder if I could pull up my multi-sim. Uh, my multi-sim here. I don't have time to do a FlyCat right now. Oh, I'm not logged in. Oh, never mind then. Screw that. So I need to figure out. Okay, let me just draw it on a piece of paper. That might actually be easier for me at the moment. I think I have some spare paper over here. And let's see if we can figure this out. So also move this off center a bit more. off-center the opposite direction. There we go. Okay. So let me try and draw this out. Where? Okay, there's my good pen. So it's gonna look something like we've got our audio here, our op amp here. I'm gonna call this ground here, and then this is gonna come in, and then here, of course, we're gonna do a split rail. So we have our minus voltage, our positive voltage, non-inverting, inverting. Inverting is gonna come over, and there's gonna be a voltage divider here, right? And then this is gonna go to ground, and then our signal is going to come into the non-inverting, right? So that way when this swings high, this goes high, and then brings this input up to equal that, and then this is the output here. Yeah, okay, I do remember my theory. So the circuit looks something like this. Input, output with the feedback loop, you got your voltage divider, R1, R2 here. And I don't... Yeah, there's no feedback for the input, right? I don't think you need a resistor here. Yeah, I don't think you do. All right, we're gonna try this out. Let's build this in the breadboard first. I just want to make sure I'm doing this right. It's been a long time since I've done an op-amp circuit. So P27. I'm gonna use this breadboard. Why does my camera not focus? Oh. So we got our breadboard here. And then I'm gonna need to get a whole bunch of jumper wires for this. I don't have. You know, it doesn't shuffle. I don't, but I'm gonna turn it on shuffle. No, music's on shuffle. Okay, so I have a bunch of jumper wires now, and they're mostly all used, but let's start by getting a voltage supply for this. And the classic one would be plus minus 15. But I'm actually really curious to see within the OP27 datasheet, which I have here, within the OP27 datasheet, what is the maximum or the minimum operating voltage? Let me bring this out a little bit more. What is the minimum operating voltage? Input, power supply. It's here somewhere. It should be here somewhere. I'm gonna turn my music down a little bit more. Input voltage, offset. Oh, there we go. Supply voltage. But that's a maximum rating. That's a maximum, though. I'm not about to ask ChatGPT for this. I might ask ChatGPT. Wait. It's here somewhere. ChatGPT is just gonna lie to me, though. Well, yeah, okay, so our maximum supply voltage is 22, but what does it work down to? What's the minimum? Because I don't want to put plus minus 15 volts. I feel like that's a hassle. I mean, I know it's a hassle. It's inconvenient. Move that up there. Okay. Yeah, it's really difficult doing everything on the PC, but whatever. So I'm gonna see if I can get away with plus minus 5 volts, which would be very convenient if I could. And also, okay, well, this is set to 12 for some reason. So let's do plus minus 5 volts. 4.9, that's close enough. And then I need to, oh yeah, I'm going to need to take these off for 1 second. And I'm going to try and get in here. Well, I don't even know how well this is framed. I'm so bad at filming, I apologize. I think that might be slightly better, although it might just be too zoomed in now. Um, okay, so, wait, no, I need a banana clip. Hold on. Okay, well, I'm going to try and color code this to the best of my ability. So, we got ground, green for ground. Try and route this and make this as neat as possible. Sure, okay, that's fine. Blue is going to be our negative voltage. Okay, blue will be our negative voltage. So I'm going to try and move this here, right? Okay, and then we'll do yellow for our positive voltage. I am reusing wires I used last week for the radio, but I'm not intentionally going to try to power up the radio from DC again. I'm going to just go straight to current limiting with AC. So that way I think it'll be more entertaining. Okay, that looks okay. How is the focus doing? Are we still good? Okay, now I'm gonna need to lay out some more of these wires. Um, Hang on. I just realized I'm realizing for the first time that a lot of these wires in this bin have not been stripped. Okay, this one has. I say this one right there, and then okay, this one also is okay. Okay, perfect. We got 3 ones that actually have been stripped. So put that away for right now. I'm gonna turn the music up a little bit because I don't know how loud it actually is. And I'm also keeping an eye on my microphone battery because I am using a wireless microphone. Fun fact, those run out of battery. And they can in the middle of a stream too, so I'm going to turn this off for a second. I never have used these terminal lugs on this breadboard before, fun fact. So I'm probably gonna need more wire actually. I'm gonna have to strip this more. Oh well. Where did my wire stripper go? Here we go. So I'm gonna try to get as good a connection as possible on this. Try to wrap it all the way around. Kind of like that. It actually looks very good. And then this should just be able to clamp down on this, and everything should be okay. So this is our ground. I'm gonna unplug it from this side because I realize I have this power supply also wired to this rail. Oh wait, except these rails actually even aren't connected. So completely, I forgot this breadboard is basically 2 breadboards in one, so I can just connect this over here. The top will be ground. And then, see, I'll have to strip this one more. And then this should be our negative, actually I'll do positive voltage first. So positive one will be the next one, and then negative one will be last. So I should just be able to scoop this wrap it around like so, and then clamp this down. What notification? My computer notification just went off. You all probably heard that. This is going to be on this side here for positive voltage. Let me just look at what happened here. Oh, I just got an email. Never mind. That's what happened. And then last but not least, we're gonna take our let's move this one back because we can get away with just using this, I think. Maybe not actually. So yeah, I'm gonna have to just, regardless, strip this one. Make this one a longer wire anyway. If this one decides to cooperate. Oh, I see the problem. This one's very bent at the end. Okay, so this should be enough wire. Jeez. Yeah, no, that's pretty stuck, isn't it? Okay, there we go. Okay, so this is going to be our negative voltage. And this should give us enough leverage, or not leverage, room, I suppose. Yeah, that looks perfect length there. Okay, cool. So negative voltage was the middle one here. And I realize I'm setting all this up just to prototype one circuit, but it's a good first stream. I see the problem as well. This wire is kind of weak for the yep, it just broke. On the place where it was really kinked on itself, it just broke. So I'm gonna have to cut a little bit more off of here. Right, there we go. So loop this around. That. Hopefully a bit more than that. Oh, my camera's not in focus anymore. I don't know what... I've tried all the settings on this camera. I cannot figure out how to make the autofocus work all the time. Just decides to not work sometimes. Yeah, it's just not working. I have to go manually reset the focus. My gosh, so annoying. Anyway. So, we got negative voltage there. Like that. Beautiful. I'm gonna try and move this a little bit closer. And I'm also gonna move this over one. There we go. Okay. Cool. I'm gonna quickly go in front of the camera for a second. Okay, cool. So next step would be to connect power, get two resistors. Let's see if I make the top one. No, I need to make. Yeah, no, actually that's true. I need to make the top one a potentiometer. I wonder if I could get away with just using one potentiometer though. You know what? You probably could actually. No, you totally could get away with just one potentiometer in this circuit. That's actually so true. Let's see. Do I have? Let's see if a 10K potentiometer work. I have some. but I don't have one that's easily adjustable. I have 1K, no 50K. I do have 100K. I have 100K. There might be a chance that this is going to contribute an offset. Well, I just realized my 100K isn't compatible with the breadboard. Alright, here's what I feared. I'm going to have to go in the other room, and I'm going to have to borrow a potentiometer. So I will be right back with this. And by right back, I mean like 2 minutes or less. Hey, I am back. We have our 10K potentiometer now. That is compatible with the breadboard. Let's go. I need to put my microphone back on. And we should be okay. Oh, I just realized this live stream is very delayed. Alright, whatever. So there we go. Oh, chat back up. Okay. And then I need basically that's everything. Yeah, that's everything I need for this. I think. I'm gonna just be like absolutely losing it. I think that's everything. So let me just put this here for a second. Wait, is this compatible with the board? It's gonna be a pretty tight fit. I think it is. It's probably not great for it, but that's probably fine. Okay, so then I'm gonna need to try to get our power sorted out here. So the first two pins, 1 and 8, are trim offset pins. 5 is not connected. Let's see, 7 is going to be our supply pin. So I'm going to try to route that. It was this one was supply, so the top one here. Eh. This is going to be really ugly by the time I'm finished. Oh, you know what? I should keep this color-coded. Yeah, so I should use yellow instead of white. Okay, so supply pin. Oh, that's the wrong. That's not a male-to-male jumper. Oops. There we go. Supply pin. And then we have our negative voltage pin, which I believe was pin 4. Yes. Which was here. Yep. Okay. And then we've got our output. Output will be white. Output was pin 6, I believe. Now, I'm also going to have to route the output down to the potentiometer. Technically, this potentiometer should give me a range of 0 to infinite gain in this circuit, but I need to route from here. I need to straighten this wire. That's what I need to do. Probably, let's see, what time is it? Oh my gosh, it's already 8 o'clock. I'm probably going to stream until 10. Well, I'll stream until I finish this circuit, and then maybe do a bit on the Zenith radio. Yeah, so output down, and then the other side of the potentiometer needs to be ground. Yeah. So ground I need to take from the very top, and let's keep with the color coding tradition, and I will try to find a green wire. Okay. Put that from the top down to here. And then the other two connections, we just need to take the center pin of the potentiometer and go back to the inverting input, which I believe is pin 2. Computer is too far away for me to see it now. I think it's pin 2, and then pin 3 should be our input signal. Just gonna grab this piece of wire for that. It's all the same. Pin 3, we have input signal, because that's the non-inverting input. So I think I've done it. So now we just need to test if I have this circuit correct. And I need to, first I need to be right back or something. So 1 second, I'm going to quickly throw up this BRB, and I will be back in like 2 minutes. So enjoy the music. If I can find the text. Okay, there we go. I will be back in like 60 seconds. Alright, I'm back. Boom. We are now ready to set up the test for the circuit, which means that I need to get a new camera angle, zoom very slightly, or way, I guess. And then I'm going to try to turn on a signal source. Let's see. Yeah, it's probably best if I do this. And then I'm going to need a breakout cable, so I need one of these splitters here. Okay, this should be fine. Perfect. Okay. Try to put this on channel 1. We've got our input right here. And ground needs to be attached, obviously, to ground. And I'll do that through this thing. Should be okay. Ground right here as well. There we go. Okay. And then I just need to measure it on the outside. And I'm going to use the... man, there's not really a great scope in my field of view, so I'm going to use a Hantex scope, since it's a bit easier to see if I can position it so that there's no glare. Okay, that's really hard, actually. It's probably okay like that. And then I need a scope probe, which would be in my personal drawer. I believe it would be here. Yes, so here we go. Hantex scope. Or it's not a Hantex scope, it's the Oan scope. The Hantex is the other one. Need to still attach ground, because this is a floating scope, so I need to ground this. Yep, and then I need to put this here, and this is kind of growing very messy very quickly. And then I need to measure the output here, times 1, and then I need to set this to be times 1. Wow, it goes up to times 10,000, that's crazy. Times 1, okay. And then, let's see, let's go up to 2-volt scale, 0 position, horizontal time base. Okay, that's pretty good. So let's just power this on. Okay, we don't see any change. That's great. Is this getting hot? No. Okay, let's turn on their signal here. Oh, beautiful. So I should... Yep. Okay. Yeah, no, it's working. Okay. I think it is. So yeah, it's going from time. It's going basically from a gain of 1. Let me see if we can fix this. Why? Just auto set, sure. Give it some time. Okay, well that really did not do what I thought it would do. Okay, well that actually looks kind of weird. Never mind. Maybe it's not working. Wait, yeah, why? What the hell? Oh wait, maybe it is clipping like way too hard though. It really shouldn't be though, because did I mess something up here? I think do I have a flaw in this circuit? I don't really think I do, right? If you connect that to there, it's very high impedance, so it doesn't flow. If the potentiometer is at the other extreme, you basically just get infinite gain. right? Yeah. Yeah. So, wait, unless I have this reversed, pin 2 should be inverting. Yeah, okay, it is. And then pin 3 should be non-inverting. And it is. So what's up with that? I'm gonna put my mic better. Okay, there we go. Yeah, so what's up with that? I don't really understand that. Um, so I mean, yeah, it is like working, quote unquote. It just has distortion. Well, actually, you know what? I might be thinking about this wrong. This could honestly just be a side effect of the voltage being too low. So let's go up to plus or minus 12 volts, where I'm confident that this works, and try again, and try again. Hello? Hello? Okay, no, it still doesn't work. Yeah, I mean, I really don't know what's up with that. Come on. Yeah, that's a weird waveform. It's sine wave, but there's crossover distortion. There's crossover distortion right at 0. So why? Like, actually, why, though? Oh my gosh, I am so dumb. I know why. I know what I'm doing. I did not plug the power into this. Oh my gosh. That is actually like a rookie mistake, though. Like, for real. So yeah, it was powering it through the signal. Okay. So, power on. Power has been applied. Okay, and then power on. Oh, beautiful. Okay, and then I should be able to take this from a gain of 1 to a gain of basically infinity, which is there. Okay, and then I should be able to drop this down without it distorting. Yeah, okay. That was my bad. Uh, trigger. My gosh, the off is all set wrong. Okay, well, it doesn't really matter. That's the problem with my scope more than anything else. Okay, so yeah, no, it is working out. You all can't see because the freaking glare. They really gotta make these screens anti-reflective. Okay, well, it is working. So I just need to take this out of the breadboard, put it on a proto board, solder it up, and then I should have a generically good amplifier circuit that can produce up to 12 volts peak to peak if that's the power input. So yeah, I got to think about how I want to put this, how I want to make this work. Okay, yeah, no, I think we're gonna be okay. Yeah, I think everything's decent here. Okay, so I'm going to call this a success. Turn this off. Probably could use some decoupling, but yeah, whatever. Okay, so then we're gonna go to this party board here. And I just realized I'm gonna have to make way for moving the camera setup over because I need to move over to the soldering station now. And I need to clear here. So if you'll come over here, and hopefully my capture card isn't unplugged when I move this, that would be bad. Uh, okay. Lab, stream, time, let's go. You know, I really need a solder mat here. That's really what I need. It's really what I'm missing. I could technically move that anti-static mat over here. You know what? I think I will, actually. I have to duck under this power cable now. I think I'm going to move my anti-static mat that I had here. I think I'm going to move it over there. I think it just looks better. It covers more of the space. Just generally has a better vibe over here, I think. Can kind of double as a soldering mat. It is a little bit dirty. Okay, so we are almost ready to go. I just need to basically, I don't think about it. It's been a while since I soldered in a way that was actually efficient. So really, I just have to. How am I going to get power into this thing? That's the question. Question on everyone's mind is how do I get power to this thing? Oh wow, that's a huge 256k pot. Or 250k pot. Okay, so I need to think about power. I could just have 3 wires come off the board. I could either go with 3 wires or 3 pin headers. Man, that's a hard choice though. Wires would make a better connection overall, but pin headers would be easier to move it around. I think I'm going to go with pin headers. I think that's probably best. I'm going to go with 3 pin headers. Actually, no, it would be 4, right? You have positive voltage, negative voltage, ground, and the input of your signal. Wait, no, actually, never mind. If I use the jacks, then... Do I even want to use the jacks? Do I even want to use this board, honestly? Maybe not. Maybe just use a different board. Like a much smaller board, you know. Let's see if I can find one. I don't know. Oh, I'm tired. There's gotta be a proto board here somewhere that is tiny and that no one is using. I mean, there's larger ones. I don't know if I really want to use one of those, though. Some more breadboards. I mean, I also know that there are some in the other room, but I don't really want to get them. There's this thing, but it doesn't have any copper vias on it. Let's see what's in here. There's a couple. I mean, someone all of the proto boards. There are just no more proto boards left. I need something about this size, but someone's already been using that one. Man, I don't know. I'm thinking. I guess I'll just use this. It's really supposed to be for a Raspberry Pi, but it's fine, I guess. And then I need to grab a socket, actually, that's very important. Now I should have a thing full of sockets here. Somewhere. It's like before, it's always somewhere. Always around. In a location. Alright, I need one. Oh wait, this one's already open, I think. Yeah, this one's already been opened. Okay, so I need one out of this giant tube. Okay, there we go. Just need one socket because we're only doing one channel of audio for this. I mean, to do two channels of audio, you're basically just duplicating the circuit at that point. Okay. Socket, and then I'm going to do a 5-pin header, right? So power, 2 power, 1 ground, 1 signal input, 1 signal output. So I need a 5 long pin header. I have 6. I guess I could just cut off one side of the 6. That's probably the easiest thing. So I got six pin header here, and then if I just, I'm gonna have to duck around this. Second, I need to find my clippers. Huh, wait. I don't have them here. I was using them. Oh, wait, it wasn't me. It was using this. There we go. Found them. Okay. So I need to clip off just one piece of this. So 1, 2, 3, 4, 5. I need to clip off 6. Okay, well that's gone. And then that should be. I've made this circuit so many times before. Now, oh wait, I just realized. Actually, no, this is good. This is better because. So everything here is actually all connected together. Try to maximize strategy here. Man, this is gonna be a difficult choice for me to make. Yeah, it's probably fine. No, actually, you know what? It's not fine. I refuse. Oh shoot, I dropped it. I'm going to put this like here, like so. Man, but that's a lot of wires to run. I wonder if it would just be better to solder the socket in first and then see how easy it would be to just run wires different places, because this circuit is very simple at the end of the day. So if I can do this elegantly without using too many wires, I think that would be better for me. Okay, try moving this. I'm gonna duck under power cord again. If the stream ever stops, it's because I've disconnected something critical. And we're gonna just get the soldering iron going here. Someone unplug this. Oh, there we go. Okay, wait for that to heat. Solder, and then I just need to solder the socket. I bet I could just run wires places. Add a few capacitors for like decoupling. Maybe a AC input capacitor. Nah, actually I don't need that. I just realized I can just tack a capacitor on it if I need that. Okay. So I'm gonna try and sit down and do this like fume extractor here. I'm so far away from chat right now, I can't see anything. What the hell? Oh, that's a piece of metal. Remember, it was soldered last. Just got stuck to the tip. One thing I've noticed about this new solder that I bought is that it just does not melt very easily. And it's like the exact same type. It's like leaded solder, 60, whatever. Not 6040, 6337. It does not melt as easy as the other one. It's slightly thicker diameter. Then again, I just do not like to use a very hot temperature by solder anyway. Another thing that could be the culprit here is that there's more thermal mass to heat up because each one of these rows is connected. But that one went pretty easily, so I don't know. I'm gonna put that there for a second, and then I tacked in both corners, so we should be good to go now. I don't need to use that anymore. Okay. So I should just be able to quickly tack the rest of these in place. Should quickly, all relative things. This is not my best soldering ever. I'm gonna go back over this. This is pretty ugly. I just want to tack this, I just want to make a kind of okay-ish connection to the socket right now so I can figure out how to... I don't have a technical, like, layout for this in my mind. It's really just, like, how it goes, you know? Okay, that should be good. I ran back over that. Okay, so yeah, looks okay. That is passable. That is a passable soldering job. So sockets in place. Now I just gotta think about how I want to run wires. Because like really, I just want there to be one ground wire. It should attach at the bottom of the potentiometer. One input signal should just go straight to the non-inverting input. And then one output. The only wire I should run is the feedback wire from the middle pin of the potentiometer. Like, that's literally the only wire I should ever run on this thing. Yeah, it actually might be a better idea for me to get the potentiometer tacked in next. Even if I'm smart about how I do this, since the potentiometer is hooked to pin 6 on this, I can run it from here to here, loop this wire back around, and then that row could be ground, because this... It's basically like I'm soldering onto a breadboard. Like the rows of 5 are all connected on the breadboard. So taking a coffee break. Let's see. I want to make sure that I have the right spacing of the potentiometer. So I'm gonna take this. I think it's decided we're going with a 10K. Grab this, and then, so this is front because it has the notch. So if I do 6 and it looks like that, then I could possibly only have to run one wire, which makes basically the using of this breadboard like terrible, but very, very space efficient. Now, the tricky part, ducking under the power port again, is how to solder this with a lot of patience. That's the answer. So I kind of just need to like balance this on something. Let's see if I can balance it on that, like that. Oh, excuse me, that should be good enough. Wow. Is that in focus? I can't tell from here. I don't know. So grabbing the soldering iron again. We just want to go back over this, solder this. Let me turn on the fuel extractor. Okay. Yeah, I think the iron was just heating up because now it's soldering. Now it's melting pretty fast. And I did increase the temperature on this since the last time I used it. Okay, cool. Yeah, so that works. Soldered that in pretty good. We are connected to pin 6. So I think I have decided I am not going to use pin headers. I'm going to go with wires. And I'm going to try to get them the correct color, so that way it's easier for me. So we do have green, and we also have yellow. Ground, positive voltage, and if I can find blue, I know we were running low on blue. If that, I mean, I thought we might have ran out. That's why I'm having a look in here. Oh my gosh, we are out of blue, but this was all that was left, which should be enough. And then for signal, we can just use whatever. Yeah, I mean, I guess I can just use the same color for input and output. I'll be able to tell which is which at a glance. Is that smart or not? Probably not. We'll just use like this white wire for the input output. Okay. Input. Let's do something different for output. Let's do like brown or something. Okay. So brown for output, and then I'm going to try to. I need to clip and strip these wires. I'm gonna try to make everything about the same length here. Whoops. Okay, well that's gone. So yeah, that looks okay. And then I just need to cut up yellow. Yellow is gonna be about the same as well. So not quite the most elegant thing, but I'd rather not have to bother with a bunch of pin headers. Honestly, if I could just like have a decent set of wire connections to this. So gonna grab this and go back over here. Again, I have not checked the stream. The audio quality could be really bad again. Probably is bad. But if it is, I apologize because I just do not have the best internet in this room. For whatever reason, this room has like Wi-Fi dead zones. And like I was testing out the stream from like literally putting my laptop like 3 feet the other direction on the other table. Because that way it would be like closer to me and I'd be able to read chat. But like the stream just was like, I mean it would work, but like the quality would be so terrible that you could barely understand what I'm saying. So it could be doing that again, but it's basically just the Wi-Fi in this room. So bad. Wi-Fi in this room is terrible. Okay, so that's all the wire there. Trying to oh my gosh. Let's talk a little bit. Okay. Right, so there we go. And then I can try to like move this closer. I'm trying to remember the pin I'm blind here. I believe 7 was positive voltage, I think. It's literally the same. It's literally a drop-in replacement for the 741. I mean, not quite, because there's a trim offset or whatever in this one. Or maybe there wasn't the other one. I don't know. This one's just basically 741 compatible. Ground. Okay, you know what? Let's solder ground first, actually. That's more important. Then we're also gonna need a wire on the other side to be to match over for the, or to make the connection back to the feedback loop. So I think ground should go right there and then face, let's see if I can get all the wires facing this way, then they'll all be easy to connect up. And honestly, if I can get the 3 power wires, smart thing to do would be to get the 3 power wires facing one direction, so they would never touch the signal wires. I just realized I don't have my fuel extractor on. All right. Hopefully that did not. It's not going to set off the smoke alarm. And okay. And yes, so if this would be power here. Oh, wait, hang on. Let me go back the other way. So like that. There we go. Brilliant. I just need to solder this in place. And then this should all be working. Okay, so wait, no, nope. There we go. That's what I wanted. Oh, it fell out again. Oh my gosh. The annoying part about soldering is trying to keep everything tacked in place. So what I'm going to do is I'm going to try to tack this in with just like barely applying heat. I'm almost going to try and use this as a third. Okay, perfect. And then I kind of soldered it to there, but yeah, okay. We got it. There we go. Okay, perfect. We got it. All right. So power, ground, and then I need negative voltage here. Now I know you're saying I could have used a those rail-to-rail op amp with the no negative voltage required, just ground and whatever, but like you have to set up a bias network anyway at the input, right? So it's basically dumb. That's what I'm saying now. But I'm trying to keep the circuit as simple as possible, not necessarily the user interface, so to speak. The input. Oh, this fell out. Great. Now, you can like twist the wires and bend them over on themselves so that they stay in more, but then it's hard to get them out if you ever want to desolder it. So I say just like try to keep them as straight as possible. And then you should just be able to tack it in place when the time comes. Like that. Perfect. So that's everything there. And then I just need 2 more wires, which would be, well, technically I need the input here. Now, bear in mind, the input is in the non-inverting, so input goes here, like this. Okay, there we go. Input is in place. Pretty decent too. I mean, it's all relative. Decent is relative, but I'm trying to cut off the tips here because they are kind of close to touching each other. They have not, but they're kind of just... Okay, and then just the output. All that's left. And then this is going to be right here, right from the tip of the potentiometer. Super, super, super simple circuit. Won't ever have a gain of less than 1, but still, it's... very simple. Oh, that's beautiful. Look at that. Okay, and then we just need to make one tiny little connection over. And I'm going to duck under the port again. Okay. Wait. Okay. Where did you go? So I need to make this one wire back over. So this is going to go from the middle pin, right? The middle pin. I should also probably do this on the other side. The middle pin back over to pin 2 here. Like that. I can just solder. I can attempt to solder the pins on this side of the board, but it is going to be kind of tricky. But I think it's actually best if I do it like this. Perfect. I can just go ahead and cut this off. Oh, my multimeter just shut off. And then I can try and bend this back. And then, oh my gosh. All right, well, I'm gonna do my best here. This is a really tight angle to get, though. Wait, I think I actually got it. Oh, dang. Not the prettiest, but I think it's in there. Now, hopefully I didn't make a mistake. And everything is good, right? Right? Alright, it's connected to there, there. Feedback all the way over to there. I think it's okay. I think it's gonna be okay. So, my handicraft. I think it looks pretty decent. I'm gonna move back over to where it's easier for me. Over to here where we can test it. And hopefully have a decent experience. So I'm going to essentially remove the 3 power lines here. And then I'm going to get 3 alligator clips. This is a similar thing to what I did for Waveform AI. Oh, man. All the time, guys. Oh. All right, there we go. 3 alligator clips. And then I need to put this. Oh yeah, and then if this works really well, but I see noise or like I see there basically if this works, I am regardless, I'm going to add bypassing. If I'm going to look at the bottom and see how difficult it'd be to add by 2 bypass capacitors between positive ground and negative ground. So then I need to connect this side, which is going to be the input here. And then the output gets connected. Wow, this is jank. The output gets connected here. So we're going to connect this up to here. It's another ground. Output is here. Gotta turn my scope back on. Okay. So let's power up. No smoke. Oh wait, I need to. First good step would be to put the chip in the socket. That would be the first ideal thing. Okay. So let's not reverse the direction here. Let's make sure it's in the right amount. Okay. Hopefully no smoke. No smoke. Okay. We get noise on the scope. Now if I turn this on, yeah. Okay. We're on 1 volt peak to peak. I'm trying to get it to a scale where I can like kind of so I can go all the way down to about 1 volt peak to peak, and I can go up to essentially infinite, although realistically it's going to clip at the power supply, and it's going to get exponential. So here's 5 volts, and it's going to clip there, right there. Okay. Look at that. I've done it. We have our audio amplifier. Is it perfect? No, because if I go all the way down to a gain of 1, and then I go down to a gain of 1 for a man, I really do not like these hello? Hello? Are we okay? What happened? Okay, so it is self-oscillating. Huh, okay, wait. Wait, yeah, no, what happened here? Something happened. Like it's a bad connection somewhere, I think. Yeah, there's a weirdly bad connection here. It's almost like the ground came off or something. I don't think that's the case. Wait, what the hell? Huh. Weird. Because that was not doing that a moment ago. Well, let's see. It could just be the trigger level is being strange too. Well, news about that. You know what? I almost think it's bypassing. Let me try adding a capacitor. This almost screams like it's a bypass problem to me. Let me just try adding a capacitor here. Let me quickly do that actually. I'm gonna go over to I'm not gonna bring the camera over. I'm gonna quickly solder two bypass capacitors, one between positive ground, negative ground, and then I'm gonna come back. And both of these should be pretty trivial to do, right? Because one is just between here and here. Okay, well, yeah, let me just do this then. It's not quite as trivial as it may appear because the preface for the capacitor is pretty tight. I'm gonna have to use needle nose pliers to kind of force it into the right location here. Oh my gosh! All right, there we go. Now I just have to make sure it doesn't touch anything. The metal body of the freaking potentiometer that's like right next to it. It's also going like right over this wire. Oh my gosh, yeah, this is difficult. This is gonna be kind of tricky to do. It might just be a thing where I give up and I just solder from the other side. Because this is not gonna work. I don't even know if it'll work from the other side. Let's see. Oof. So ground here. And what is this? 5 volts there, yeah. Okay, no, that will work. That will work. It's just going to be really, really sketch. Because it's passing very close to other conductive things. So so we bypassed it. I think these are 10 nano. They're like 104, I think. Or not even. They're 473. I didn't even look at what I grabbed. I just grabbed it out of the freaking drawer. Well, let me grab another quote unquote 10 nano. It's another 473, okay. So this is a 4.7, I believe. 473 is not 10, but it's 4.7. And then I need to attach it between here and ground. Okay. Man, that is close though. Okay. So bypass capacitors have been installed. We have two 4.7s. Did that fix the issue though? Did that fix the issue? somehow? I don't think so. Okay, now that's gone now. There we go. I just realized this is the time of year when I generate so much static electricity around things that's actually kind of crazy. Okay. So, power on. Okay, no magic smoke. Better or worse? I mean... Wait, it's better, right? I feel like this should be 1, right? Am I insane? This should generate a gain of... I'm trying to back this up because I feel I just have a subtle, sneaking suspicion that this is just because this is grounded well. Just a sneaking suspicion. It's almost like it's just picking up noise. Yeah, it's almost like this is doing nothing right now. Okay, well, no, it is doing something. Like, look at how awful this looks, though. Like, this is crazy. This looks terrible. Huh, I wonder if... I don't know. I wonder if it could be the chip. I almost don't want to blame the chip, but it could be the chip. Hmm. Hmm. Very mysterious, and I don't really like it. Yeah, that's so weird. That is so bizarre. I'm gonna be right back. I'm gonna grab another OP27. Maybe we have one here. Oh yeah, no, we have another one here. OP. This is not OP27. This is OP275, but I think it's the same thing. Pretty sure it's the exact same thing. This is what I have here. Oh, my scope says low battery. The writing is a little bit different. Oh, wait, okay, no, actually, no, never mind. I have an OP276. Wait, what day was I looking at? I was looking at an OP27. Okay, well, maybe that's the entire problem. Maybe I didn't read the freaking chip that I had. Okay, well, I don't think it's actually. I definitely know the pin is going to be a little different. OP275. Oh, I've looked at this before. Well, you know what? I stand. The 275 is not the same as the. Okay, well they don't have OP276. I guarantee you this is the OP27. These are all 275. Except for this one, which is a 276. I don't even know what to believe anymore. Crazy, right? I'm gonna put this under the microscope. It looks like it says 276 on it. So I guess it could be 275. Let me just look at this for 2 seconds. So I built this. Gone. Okay, no, it says OP27G. No, maybe. I think it says G. It's either G or 6, it's not 5. So that's a problem. Or I guess it's not a problem. Let me go back to looking at this. Is the G suffix anywhere? I mean, I highly doubt. Well, low noise precision op amp. OP276. Is this actually a real device? I have no idea. I'm gonna go grab some more coffee though. I'm gonna turn the coffee pot off. This webpage is never gonna load, is it? That's a problem. All right, well. I'm gonna go off the assumption that it's a 2.7. I think that's a good assumption to make. Let me try a out of pure curiosity and nothing else whatsoever. I'm going to try a 741 in place because I know this is pin compatible. Like I know this is pin compatible. Like that it's just like a fact. I know my 741 pinouts. The reason why I went with a 270 is because it's JFET, so it's tolerant to like higher voltages and generally more performant than 741. Well, that's more promising. Well, no, it behaves the exact same. Okay, so a 741 behaves the exact same as this thing. So, what have I done here? Clearly something is messed up. Like, what? This was not happening before. Like, I don't believe we're getting 20 volts peak to peak. Like, what are we doing? Huh, this makes no sense. It's almost like I'm missing something obvious here. Hmm. I'm gonna go over this with fine-tooth comb, I think. Um, I almost feel like I made like a bad soldering joint at some point. Let me, excuse me, I just need to reach around and do that. I'm looking over this right now. I don't really see a problem. All of the solder joints look okay. The input looks okay. The input is the non-inverting. What do you think about this, though? No, the fact that, like, this should, I don't know, like, how else to describe it other than the fact that this should just work with zero issues and zero problems. Input, output. Yeah, it just does not. It just distorts, though. Okay, let's go to, I should have 5 volts now. Okay, so what tips me off that it's like a interference problem is I'm getting 60 hertz ripple on top of everything. And you know, this part works pretty well, but also at minimum, I should be getting the same output as I am input. And I am. It's actually working. It's just shockingly enough, the input is doing weird things. Okay. Okay, this is weird. So, okay, yeah, no, something's up with my signal generator. Look at this. Okay, this is just directly connected over now. Like I'm bypassing my circuit. Hello? I'm turning this off for a second. Okay, okay, okay. Okay, with no signal on the signal generator, we're getting like terrible, terrible 1 volt peak to peak interference. I'm gonna power cycle this. Oh, you know what? It actually just could straight up be the fact that this is out of battery. I just realized that. This can do weird things when it runs out of battery. Like that. Like whatever it's doing there. Let me plug it in. I swear, if this whole problem was because my scope was like tripping out because its battery was low, I'm gonna be kind of upset. I've been goose chasing a noisy signal, and it's because my scope is on low battery, unlike, you know, mine. Well, I'm gonna plug something bad here. I think I can get away with playing this. so it's a USB-C charger, right? See, like, look at that. I haven't touched, like, what is going on there? I'm grabbing this, and it's doing weird stuff. Like, what is this? All right, I'm plugging it in. Let's see. No, now we got different noise pattern. This video is not sponsored by Owonscopes, by the way. I've never had this problem with their test equipment before, but like what? I'm just shaking the scope probe. Like, I'm just shaking this up here. This is my nice scope probe, though. It's not. This is not the issue. What? Like, what? You know what? It actually could just be the issue. Oh, yep. Yeah, no, it is the issue. So, my scope probe of, what, 5 years has decided to kick the bucket. I think. It's breaking at the tip here. I just noticed that. It probably wasn't making a ground connection. So I can try, I don't know really what that is or does, but I mean, that looks different, so. Let's turn this back on. 100 millivolts. Let's go up to 2 volts. What the? No, what the hell? All right, let's unplug this. Oh. Okay, so it is this is new. This is a new one for me. This is new. This is like genuinely baffling. Well, I think it died. I think my really nice scope probe has kicked the bucket, guys. All right. Well, okay, so that's what it's supposed to look like. And then if I, actually go back through my circuit, because there's actually nothing wrong with my circuit. It was working the entire time. It's just that my scope probe has decided to give out on me for no reason. I'm glad I found that out on stream. Then we get no. Oh yeah, perfect. So this is what it was doing before. And now I bet, well, that's just the way that's going to be, huh? I bet if I go back from the 741 to the 27, that everything will be fine and it will work again. I cannot believe that that was the entire issue, was the my scope probe decided to break at the oscilloscope part. That doesn't make any sense. I'm about to replay the VOD after this and see the part where it stopped working. I must have like accidentally yanked on it or something. So if I, like kind of force it to work, I'm gonna have to throw this out now because it's bad. But yeah, no, there's no problem with the Man, this is kind of sad for me because this was the very first scope probe that I ever owned, was this one here. It came with this oscilloscope that's out of frame, sitting up there. Oh yeah, I don't know what. I might do a teardown of this, I guess. Yeah, it's breaking right there. Although that's not even the part that's like breaking, it's this up here when I fiddle with this that it does weird things. But I mean, yeah, it's just really noisy and inconsistent, which is not really something you want in your scope probes. You want them to be pretty consistent. Yeah. Yeah, man, that's so unfortunate. I don't know. Well, at least it works, so well when it decides to not crop out. Whatever. Okay, so our circuit works, so technically now we should be able to move on to the actual point of the first part of the stream, which is getting AM modulation to work. Man, it is so unfortunate. I'm like actually upset with that. I might take a quick break after we get the AM going, just to like get the radio ready. I also may or may not switch over to streaming or going live on TikTok for that. We'll see how that happens or what I have to do to even do that. Um, but yeah, I don't know. This seems like it would be problematic. And the terrible part is that this is such a high quality probe compared to the clones of this time. You get clones of these like 100 megahertz probes that come with stuff and they're just really bad. You buy them from Amazon, but this one is actually nice. Like I never had a single problem with the contacts here or the little grabber or the switch. It still feels really nice. I cannot believe that it finally broke. Well, okay, this was like 5 years old, I guess. I got this like 5 or 6 years ago, but that's still kind of crazy. Yeah, I don't know. Pretty sad, all things considered. But hopefully now we should be able to get some full AM going. Um, and I'm going to do that after I clean this whole thing up here. So now that we have our little amplifier board, we can sub that in wherever we need to amplify a signal. Well, a low voltage signal. So we have that going for us now. And with that, we should be able to do a lot cooler things. And I'm gonna have to move these three out of the way as well. Gonna just move these back to this drawer. Okay. And then also, I don't need the alligator clips or the alligator clips, the hook rat things as well. We're just gonna go straight into the next part of this, which is testing an AM modulation here. So, let me move this as well. Move the oscilloscope over here, just charge it because it does keep saying battery. So, move that over there. And the next part of the stream is going to be involving this whole new piece of test equipment I got, or it's kind of a stretch even calling it test equipment, but it's this cool RF generator here, which is really not a piece of test equipment, it's a kit. So this, let me actually double check when the date was for this. So this is the night, what is this? The KG650. Oh, well, I just switched to the different tab. Hang on, I need to put it here so you can see it. Yeah, so this is the, let me also, I'm sorry, I'm moving things around on the stream. Um, yeah, so this is the kind of manual thing for this, and then I believe the full data is here. 1963 it looks like. So this was a kit back in 1963. And hang on. I'm still moving things around. Okay. Yeah, so this was a kit back in 1963. Oh my gosh. I'm sorry, I'm not a great streamer, guys. Oh, if I minimize it, it disappears. Awesome. Well, okay. So yeah, so this was 1963, and basically this just came with like parts, and you put it together, following this like instruction manual type thing here, which is cool. And this is like detailed. This is like what would have come with it, I suppose, and it shows you how to put it together. And like, yeah, it basically just shows you everything. Cable assembly, completed wiring view, how to assemble the cable, how to assemble pointer and knob to the tuning shaft, how to use your generator, even how to put together the handle part of it. So pretty detailed kit. Two vacuum tubes inside this. One of them is a 6C6, and then the other one is was a 6C4, I think. And the other one is a 12AT7. It's a 12A something. But yeah, just two vacuum tubes for this. I'm sorry, I'm also gonna, I know Master Bootmaker is really cool, but I'm gonna turn the music off for just a little bit. Yeah, so this one only has two vacuum tubes inside of it. Um, and the cool part about this is that we're gonna try and use it. I mean, I already powered it on, and it did have. Okay, so this was sold to me as working. I think I paid like 30 bucks for this, working, which is not bad. Um, so yeah, good condition. Someone did mods to this, right? So I opened it up. Obviously, the first two mods are that these were, I think, RCA or a weird style of jack connector, and they replaced them with BNCs. So these were not originally BNC connectors. So I didn't have to do that. That was already done. That's really nice. Opened it up. Pretty much all the electrolytics. I think yes, every single electrolytic, every single like not like paper capacitors, obviously, but like I'm pretty sure they even changed like the disc capacitors in this thing. It's completely recounted. I think it's had a modification done to it to make it perform better. I believe in a certain frequency range, it can kind of get distorted. And there's like a modification that is like a potentiometer who's been like lodged inside of it. The electrolytic capacitors are like modern. I mean, modern. I think they look like 90s capacitors, maybe 80s capacitors, but they're still good. I mean, they still should be good because they're like nice quality. Um, well, so yeah, this thing has been completely redone. Obviously, it works fine. One issue I did find with it though is that the tube for the modulator oscillator is weak, and that controls both the internal modulation but also the external modulation goes through that tube. So if it's kind of out of its socket, or like the socket doesn't have a very good grasp on the tube, so it can kind of get like basically I had to put the tube back in several times, and we'll see if it still works after it's been sitting for this long. By this long, I mean a day, because I looked at this the other day. I'm gonna go take a drink of water because I might be a little bit dehydrated. Oh, I'm all out of water. I'm gonna have to go get some more water. Well, I'm going to next part of the stream, I'm gonna go get some water, is going to be basically using this, using its internal, and then finally we're gonna switch to external modulation, modulating an audio signal through this, and then pick up on a working radio, our very own AM radio station in the lab, because I tested, I cannot get any radio at all, like not even FM radio within this building. So we are gonna have to make our own radio stations if we want to test the Zenith radio. But yeah, I will be right back. I am going to be getting water. Let me just edit the text. Okay, there we go. Okay. So yes, I'm gonna be back in a second. I'm gonna go fill up this water bottle, and then we're gonna hook up and make our radio station. Fingers crossed, hopefully. And yeah, I will see you all then. So I am back and putting my microphone back on. Hello, hello. Is the stream still alive? Okay. Oh my gosh. What do you mean the YouTube's yelling at me right now? I swear I changed that setting. Oh God, OBS. It is changed. YouTube's a liar. Okay. So, yes, so AM modulation. Let's get this. So I'm going to first plug this in, which I think it already is. Now, the other thing I want to introduce you all to, let me just go like freestyle with the camera for a second. Up here I have a current limiter with a light bulb. And I think I actually don't remember because I modified this thing so long ago. This is like an old power conditioner thing with a giant transformer inside. It's 3 amp. I think I made this an isolation transformer, but I can't remember. So I have an isolation transformer and a variac. So altogether, this is like variac plus isolation plus current limiting all in one. So that's what I'm powering this thing up through. Um, and yeah, let me just hit the power on the variac. 110 volts. And okay, well, this was already on. Okay, yeah, so it's on. It's hard to see. In fact, it's impossible to see. Let me turn off the lights. It's really dark, but there is a green light right there. So that's the indicator light. It's like almost impossible to see otherwise. Um, so yeah, so it is on, and RF output is hopefully producing something. I did check this just yesterday, and it does work. I seem to have misplaced my BNC cables though. Let me, oh yeah, okay, so they're in here. So yeah, what we're gonna do is we're gonna split this off, I believe. Wait, actually, why do I want to split this off? Oh yeah, no, I remember. I need to, I'm gonna turn this off first, and then I'm gonna hook this to the RF output, and then RF output goes to my scope. Now, let's go ahead and use the Hantex scope for this, because the O1 is still recharging. So Hantex scope, I'm going to leave that unterminated for now, or open for now, and then I'm also going to feed a modulation signal into this, so I'm going to need one more BNC. Um, and let's see if I can, so we're going to probably want to use, I'm going to zoom back a little bit more. I'm going to feed the audio RF in from my function generator. So let me turn it to internal modulation first, so that way we're getting, I believe it's around a 400 hertz modulation. I'm also going to turn the gain all the way down. Actually, I don't think that has an effect. I just realized. I think I think this is modulated no matter what. Okay, anyway, turn this on. And then low actually is the highest. This is basically not level, but attenuation. So low attenuation is the highest level. So we'll see what my scope shows. Man, I am dehydrated. Okay, so I don't even know what frequency I have it on, but yeah, so as you can see, really not a great waveform out of this thing. Now it's RF, so all really just needs to be somewhat in the ballpark of having a frequency, and we should be able to pick it up as a radio station. So I need to adjust the whole off a little bit. Whatever. Um, so yeah, so it's on the lowest, no, it's not even on the lowest range. So for example, wait, no, actually, yeah, so on B range, if I adjust it right about to there, it should be about 1 megahertz, right? So what are we at, 950 kilohertz? It's kind of off a little bit, isn't it? Okay, so that's about 1 megahertz. Let me go to measure. Oh yeah, that is slightly off, isn't it? Wait, maybe not. Yeah, no, it is slightly off. It is slightly off. That's weird. It wasn't like maybe when it warms up it'll be better. Or actually, maybe it's not maybe because I'm modulating it right now, but theoretically if I go down to something like A range and I do something like 160 kilohertz, you should be able to see the modulation pretty clearly. Yeah, okay, so there you go. There's your 400 hertz modulation. Right, because I'm on 800 microseconds per division. So, wait, yeah, so like, wait, it's about one division. Was it about 2 milliseconds? Yeah, it's about 800-ish. Or, yeah, 800, I think. Anyway, so basically, we just need to hear how this sounds. Now, you may ask, how do we hear how this sounds? This is RF. Well, we can literally just feed it into a radio. It's like that. It literally is that simple. With this RF stuff. So I'm gonna take alligator clips. Well, you can't see them. Alligator clips and a BNC. And okay, I'm not gonna get rid of this, but I'm gonna shrink it down a little bit. And we're gonna go into the other side. Here, I'm gonna put this as a face cam. There we go. I'm gonna put it to the other side here. So here we have our RF, and I need a radio. Um, so I'm gonna go grab a working solid state 80s radio, which I have lying around here. This is an Emerson weather radio, all-purpose AM/FM TV sound back when TV was over the air. It's got a nice long antenna. Now, this is actually in for repair. I I broke this about 2 years ago and never fixed it. The weather radio is not working in this, which is like a completely separate band that you push this button in up here. It switches to the weather radio band. Now, you still can pick up the weather radio on the TV band. You just have to tune out to it. But the weather radio, like dedicated weather radio station, which I believe is on the back here, it's about weather band 162.55. And yeah, I think that is within the TV range. Anyway, the dedicated band doesn't work anymore for whatever reason. So I need to fix that. Um, so I should just be able to power this on. Now, you probably can't hear anything because I'm mic'd up pretty well. There's no other audio, but um, I should just be able to grab a capacitor and go right into the antenna with this. Um, so let me grab a 10 or maybe even 100 nanofarad capacitor. Let's see, what is this? This is it's impossible to read. That's what it is. Let's see, we're gonna grab yeah, 100, I think, 100 nanofarad capacitor. And I'm gonna take uh an alligator clip thing. And I actually do know, fair warning, it may actually end up interfering with my microphone. I just realized. Like the audio may start cutting out because of this. Because I'm basically trying to couple something over here. So we just have the signal feeding into a capacitor, and I'm going to clip that onto the antenna. And then right now it's not the right frequency, so we just need to tune to where the radio is. And I am going to try to uh, get you all to hear this. I actually don't think you can. I don't know if you could hear that. I don't think it's my microphone isn't picking it up for some reason. I have no idea if that's coming through. It from OBS, it looks like it's not actually working, which is kind of unfortunate. Yeah, I don't know. But to my ears, the 400 hertz modulation is now working. So I'm going to flip it over to external and power on my function generator, and I should be able to just hit it with oh yeah, sorry, modulation's down. So that's a 1 kilohertz tone right there. You probably still can't hear that, but that's coming from function generator. I can change the frequency. Oh, well, I just turned it off. I'm gonna turn it up a little bit more for you all. Yeah, I think this microphone does such a good job of canceling noise that you can't hear that, it looks like. But it's loud. It's like a loud sine wave tone. Maybe if I change the waveform, it'll be more intelligible. Let's see. That's a square wave. It looks like that one's being picked up a lot easier. And this is completely like generated by the RF, because if I change like basically the radio station, it basically devolves back into static. Now, the cool part is I can go down to incredibly low RF levels if I tune this correctly, because this is a properly tuned radio. So you can see on the scope, well, maybe you can't, but that is about like 100 millivolts peak to peak going in instead of like a volt or more. So incredibly small signal. That's 50 millivolts, and I can still in the static. So yeah, so this is working very well. The radio is very, very sensitive, especially if I tune this. So we have our bootleg radio station, but I want to add music, which is why I built that amplifier circuit so we can feed audio from my phone into the circuit, amplify it up to enough level where I can feed it back into this our essential like radio station transmitter, our modulator, and then hear it on the radio. So that's basically the last part of the stream, if I can do that. I don't think I'm going to get to the radio. I am going to try to stream again tomorrow. If I have the room to myself, I will be doing a dedicated Zenith radio stream tomorrow. But for the last part of this, I just want to try to get a music over the radio sort of thing going here. So I'm going to put my microphone back on. I'm going to turn off the radio. I'm going to turn off the modulation, so we won't need this anymore. But we will need to backfeed audio into here. So I'm going to turn off our modulator and bring aside the radio for a second. So next thing is employing our circuit that I have here in essentially trying to backfeed audio from here into here. So essentially, it's actually really simple. What we're gonna do is grab a well, first things first, I need to get a USB-C to aux converter from my phone. Um, USB-C to aux. I need a USB-C to aux, and then I need a aux to. I just basically need like an aux breakout cable of some sort. No. Oh, there we go. It was unfocused for a second. Sorry, y'all. Okay. I need an aux. Aux. Okay. Well, I'm just dropping everything here. I need an aux breakout cable. I thought I had my Apple like thing. Didn't I had that here somewhere. I know I did. Maybe I put it. Wait, actually, where did my Apple like cord go? Did I put it down in my adapter drawer? I don't think it would have, but maybe I did. No, I have USB debuggers down there, but I don't have an audio cable. What happened with that? Huh? Oh, I plugged it back in here. Okay, that's what happened. So yeah, I'm gonna probably play audio from my phone, so I don't need the USB-A adapter. Um, so I need an aux breakout cable, which I know there are a couple floating around. I don't have any idea specifically where, but they are in the room somewhere. And I know I will find one eventually. Oh, well, this is one of the capacitors I was using previously. Okay. Let's break out. Um, hmm, okay, where would I be if I was an aux breakout table? Like I know there is one in here, and I saw it like a couple days ago, really. There really should be one here. Oh, I found it. Okay, well, no, I didn't find it. I found it. I found the second one. Wait, this is another false one. Why did people solder this together? Wait, I don't understand that. I mean, I technically could use these if I wanted to. They're just soldered together. Okay, well, I'm just gonna use one of these because I don't really want to waste a ton of time looking around for one. Unless they're in Ruffles' drawer, they could be. There could be a couple of them in here. But oh wait, okay, that's the wrong gender table. Um, but I guess I could use another adapter. Yeah, so I think this will be fine. So if I use one of these adapters I found, a double aux to aux, and then this cable here, I make sure to not ever connect these together, then I theoretically should be able to play audio from my phone and have it come out here. Okay, so this is what I came up with. Okay, well, you can't really see all of it. Breakout cable, extension cable, audio adapter. So phone, and then oh my God, Twitch notification. Um, and I'm going to try to plug this in. Well, I'm not even gonna try and plug this in. I'm gonna just try and um use a couple of uh uh clip lead cables to bring it over to there. So here are a couple of like clip lead to clip lead adapters. So I'm going to clip off of the ground first, clip off of the ground, and bring this over to the ground here. And I just realized you can't see what I'm doing, so I apologize. Bring that over to the ground there. Clip here, and then bring this over. Except it's stuck for some reason. Okay, there we go. From the actual audio signal over to the ground. And then here, this is going to go to the input. Okay, well, yep. And then the only other thing I need is the clip lead cable to be output. Now, I'm not going to feed this into the generator just yet. I'm actually going to do is I'm going to feed it into the scope to make sure my phone audio is working because I've had problems with this in the past. where the phone audio has been the culprit the entire time. So I'm going to replace this with this, and I'm going to back up a little bit more, and then come up a little bit more, and then focus everything. Okay, so I just need last but not least, I just need to power this circuit. So let's see. This is actually going to be kind of tricky, isn't it? Well, not tricky, just kind of inconvenient because I'm gonna have a bunch of wires everywhere. So um, nothing's really tricky per se. Okay, that sounds kind of arrogant. Um, everything is just a trade-off, is what I meant. Really, all life is just a trade-off. Okay, so 12 volts or something like that. Okay, boom, boom, and then I'm gonna have to clip onto this and then clip off of this. So ground, and then I clip the grounds to ground, and everything is grounded that needs to be grounded. These clip leads are so cheap that they only work once in a blue moon. And I just lost ground. There we go. Okay. Okay, there we go. So theoretically now, if I play audio from, wow, I have a lot of it's blowing up my phone. Okay, let me go to my frequency generator app that I have, and let me put out just a nice, chill sine wave at whatever frequency. I don't know. Is this? Oh yeah, no, it is working. Okay, we're good. I don't really. Okay, yeah, we're good. Oh wow. Yeah, we are good. We are. Oh wow, we are clipping. We're so good. We're clipping. Look at that. Look at that. We got a decent audio signal at 2 kilohertz or something like that. We really don't need it to be that much. I will take it down a notch or two. Okay, and now theoretically, I go straight from this into this and flip this, and my phone dies. Hopefully not. It'll actually be really bad. And theoretically, I take the radio and I take the output wire. Okay. Okay, well, it's not loud enough. Oh yeah, we got it. We got it. We got it. So now theoretically, oh my gosh. No, I don't want to watch an ad. Thank you. I'm about to get copyright claimed for probably some of this, but it'll be kind of funny if this was the one portion of the video that was copyright claimed. But let's try um I'm trying to think of what I could possibly play that would not get me a copyright strike. Probably video game music, maybe. Oh yeah, we got it. I'm gonna go up to 15 volts. Oh yeah, look at that. Well, let's see if you can hear it. That sounds amazing. And my microphone really is not picking that up, but we have a radio station now. Yeah, so it is working. Yep, it's working. Yep, it's working. Well, I'd say that's success. I'm gonna play one more song and then I think I'm gonna call it there. Yeah, so this is up full. My phone is on full volume. Yep, yep, it's working pretty well. I'm shocked, honestly. I'm gonna film a TikTok really quickly. Um, but yeah, I think this is a good place to leave it. Um, I'm happy with the progress that I have made thus far with this. So I'm probably gonna end stream, film a TikTok like interlude video, not a video in the proper series. But yeah, we tonight we made an amplifier circuit with an op amp, non-inverting op amp. Then troubleshooted that circuit, prototyped it, made it, then troubleshooted it, then got our radio station. It's really just an RF generator modulator. Tested out, tested our circuit with this, and successfully got music playing from the phone, being amplified, modulated, and then picked up through the radio just with a simple clip lead capacitor. So we can use this setup to test AM with the Zenith, but FM is a different beast. This thing can go up to 112 megahertz, which is technically just barely enough to cover the FM band. It doesn't do FM modulation though, which is the problem. So we're going to need to build an FM modulator circuit maybe? Like I don't know. Like I don't think I could do that because I don't think like I'd have to study how FM modulator circuits work, and even if it's possible to do something like that on just a simple breadboard slash proto board, because you probably need precision components. You probably need to make like a whole ass analog circuit. There's probably no like wonder IC that does FM modulation at those frequencies very easily. So yeah, that's what I'm mainly worried about. 112 megahertz is like no joke. There's like not a lot of op amps that can operate at those high frequencies. So yeah, that's kind of what I'm worried about. But other than that, I think this has been a great stream. So for whoever's watching, I'm going to end, and I probably will be back either here or on TikTok tomorrow, doing proper videos with the Zenith. So yeah, I'd say this has been pretty successful, and I will see you all tomorrow. So have a nice night, everyone. It's just about after 10 o'clock, so I think I am going to end here. So yeah, I will see you all tomorrow.